Continuing our discussion on solving systems of linear equations with two variables, try this example on your own. 1/4 x minus y equals negative 1/3, and 3x minus 12y equals negative 12. Let's work this problem together. 3y minus 4x equals 2. 3x minus 4y equals negative 5. We'll begin with graphing. Just like before, we can get it in slope-intercept form, or we can make a table of values. Making a table of values just means you pick a value for one variable, plug it in, and find the value for the other variable. So we can make a table for this one just to be different compared to the previous lesson. Do notice that these two equations are written in different orders. The first equation starts with a y term, and the second equation starts with an x term. So we want to make sure that we're being really careful about which variable goes with what. It takes a little more work to plug in values to find a table, but that's okay. We can still try it. I'm going to take this first equation and I am going to solve for y because I think it'll be easier for me to choose values for x, plug them in, and get answers back for y. So solving that first equation for y, we would get 4x plus 2 all over 3. Solving this second equation for y, we would get 3x plus 5 all over 4. Lots of negatives in that second one. The negatives will all cancel. If you need a moment to work those out on your own, pause the lesson, try them out, come back. Now, if I select, let's say, negative 2 for x, 4 times negative 2 plus 2 over 3, that's going to be negative 8 plus 2, negative 6 over 3. I'll get a negative 2. If I plug in negative 1, 4 times negative 1 plus 2 over 3, I'll get negative 4 plus 2, negative 2/3. Plug in 0, we'll get 0 plus 2 over 3, which will be 2/3. I plug in 1, 4 times 1 plus 2 over 3, 6 over 3, which will be 2. I've got some integer values that I can graph, so I'm going to use those. Negative 2, negative 2, and we'll make this first graph purple. And then 1, 2 there. And I can grab my ruler. My y-intercept is 2/3, which is pretty awkward. So graphing with slope-intercept form is going to be a little tricky. So there's our first graph. This is that 3y minus 4x equals 2. Finding values for the second equation, we could try the same ones. Negative 2, negative 1, 0, 1. So I've got negative 6 plus 5 over 4, negative 1/4. Plug in negative 1, we get 1/2. Plug in 0, we get 5/4. Plug in 1, we get 2. Now these values aren't that great. If we wanted to try one more value, we could. To make sure we get another whole number, I'm just going to pick negative 3, and we'll get a negative 1 on that one. So I'll pick negative 3, negative 1, and 1, 2. Oh hey, there's our intersection right there. Convenient. And 3x minus 4y equals negative 5. And we get that solution right here at that intersection, 1, 2. Now that did take us a pretty long while to plug in values and solve for y in two equations. We could have done it, but also notice that our y-intercepts for the two lines are fractions. That might be difficult for us to graph precisely in this situation. Now let's see how we would use substitution. Writing these equations down again, 3y minus 4x equals 2. 3x minus 4y equals negative 5. Substitution says choose one, solve for a variable. And in this case, there isn't an easy choice. All of my variables have coefficients on them that are not 1, so I'm going to be dealing with some fractions in here. So it really doesn't matter what we pick. I'll pick the first one and solve for y. No particular reason that I'm doing it, but we'll just try it out. 3y minus 4x equals 2. Add 4x. Divide by 3. We get 4x plus 2 over 3 is y. Since I used the first equation, I'm now going to use the second equation. 3x minus 4y equals negative 5. And plug in this expression into where y is. So 3x minus 4y equals negative 5, and we'll stick that y in there, 4x plus 2 all over 3. We'll plug in our expression for y, And we've got some fractions to deal with, but let's see if we can solve for x here. 3x minus, I'm going to treat this as 4 over 1, 16x, negative 4 times 2 will give me negative 8 all over 3 equals negative 5. I don't like that denominator there, so let's multiply by 3 on everything. We'll multiply the whole thing by 3, get rid of that denominator. 9x minus 16x minus 8, so that 3 is going to cancel, equals negative 15. Right? 3 times negative 5, 3 times the fraction, 3 times 3x. Distribute that 3. And then 9x minus 16x will give us negative 7x. We can add 8 to both sides, and we can see that x equals 1, which is what it should be, because that's what we got before. Now taking x equals 1, I've used both equations, so I can use whichever one I want to this time around once I get one variable solved. It doesn't matter which equation I go back into to find y. As long as the equation has a y, we can use this x to find y. I'll use the first one. 3y minus 4x equals 2. So 3y minus 4 equals 2, add 4, 3y equals 6, y equals 2, and then sure enough, that's what we ended up with, 1, 2. And there we have substitution. To do elimination, we have to make sure that our equations are in the same order. So before, when we had 3y minus 4x equals 2 and 3x minus 4y equals negative 5, we need to rewrite them first so that they are in the same order of terms. Negative 4x plus 3y equals 2, 3x minus 4y equals negative 5. If I try to add these equations right now, negative 4x plus 3x will give me 1x. 3y minus 4y will give me a negative y. So I don't eliminate a variable. Remember, the goal for elimination is that we eliminate a variable. So we need to see if we can multiply one or both equations in order to cancel. And because I have a 4 and a 3 and a 3 and a 4, I don't get to just multiply one of the I could multiply one of the equations by 3/4. I could multiply that first equation by 3/4. The problem with that, though, is now I'm dealing with fractions, and I really don't want to deal with fractions as much as I can. So I can multiply the first one. Let's see, which variable do we want to eliminate? Let's eliminate x. Remember, we have to make a decision which one we want to eliminate. So if we eliminate x, I want to multiply that 4 by a 3 and this 3x by a 4 so that when I add them together, I get a cancellation to happen. So multiply by 3, and the second one will multiply by 4. We already have opposite signs, negative 4x, positive 3x. And then just make sure that when you multiply, you're distributing that 3 to all of the terms in the equation. So 3 times negative 4x will give us negative 12x. 3 times 3y gives us 9y, and 3 times 2 is 6. And then on the second equation, 4 times 3x is 12x. 4 times negative 4y is negative 16y. And 4 times negative 5 is negative 20. Now adding these equations together, the 12x and the negative 12x will cancel. 9y minus 16y is negative 7y. 6 minus 20 is negative 14. Divide by negative 7, and we get y equals 2. Since I've used both equations, I can now take that y equals 2 and plug it into either equation. It doesn't matter. So the idea with these systems is once you use all of your equations to get part of your answer, then it doesn't matter which equations you go back into to get the other variables, as long as those equations have those variables. So y equals 2, back in, it doesn't matter. Let's put it in 3x minus 4 times 2 equals negative 5. 4 times 2 is 8, add 8. So x equals 1, and we get the same answer. In this situation, since we got an answer, the system is consistent and the equations are independent. We got one answer, so we have independent equations. We have two different lines graphed, and the system's consistent because we have a solution. Next up, we'll look at one more problem. In the next problem, we won't have the situation of consistent, or independent. We'll see what happens when one of those changes and how that affects all of these methods.